and greet here on the YouTube chat our first speaker, Roberto Cortez. Here's your turn to.
Hi, I mean, so much enthusiasm. I'm not sure if I can take that, but I'll try. Yeah, so thank you so much for having me here. It's a real pleasure to be here with you today, and I hope the audience has a good time listening to all the amazing talks that you schedule for them.
Thank you. Have a good time speaking. Enjoy and good
Okay,
luck.
thank you very much. Okay, so hi everyone. My name is Roberto. So thank you so much for joining this session. As Antal mentioned, I'm gonna talk a little bit about Quarkus. Maybe you have heard about that, maybe you haven't. But my plan for the session is to just make like a quick introduction, talk why Quarkus can actually help you into the cloud if you even if you already have some cloud applications or if you're planning to move to the cloud, and then hopefully I'll still have some spare time uh, to do a couple of demos so you can actually see Quarkus in action. Um, so let me actually go and go to my slides and share the screen. So hopefully everyone is seeing the slides. Can you confirm? Hello? Just to make sure. Okay, wonderful. Yeah, just wanted to make sure that the slides were okay. Um, and yeah, so for Quarkus, guys, so for Quarkus is, if you haven't heard about Quarkus before, all right, so Quarkus is a completely open source stack that you can use to write any kind of Java applications. It can be things like Cloud Native, Microservices, and serverless, of course, which tie more closely to the cloud. Now, as you're going to see for the presentation, there are other cases where you can use Quarkus. So Quarkus is not only for these cases. You've seen Quarkus being used to write command line applications or even monoliths. So it's not really limited for these use cases, but um, those were like what we had in mind when we designed Quarkus. Now, of course, the second question that comes up is, okay, why Quarkus? I mean, why another stack? Why another Java stack to write Java applications? There are already a bunch of them out there, and they're amazing. They're great. But we believe that Quarkus can offer you a few different things that we're going to try to make clear during the presentation. Now, to answer the question why Quarkus, we have to look into the a little bit on how the JVM operates and how it works and how it actually has some impact when you're running things, not only in the cloud, right? This also applies into bare metal, but when in the move on the cloud, this became a little more obvious and a little more evident, right? Now, when you look into a JVM process, there's always going to be some kind of overhead involved, right? So it's going to be an overhead when you're going to start the application, right? So your application not always gonna is not gonna instantly start. So there's going to be a overhead when you have to load stuff from the application so your application can run. And there's also memory overhead with things that they are required in memory that they're going to occupy your memory, right? So these two things are actually important because those those of course are going to impact your cloud prices or your what you have to pay for your cloud provider in the end of the month, right? So usually when you look into cloud providers, you have things like you have to pay by CPU, you have to pay by memory, and when you start to look into things like this, well, and you have to scale with a bunch of nodes, then all of these add up, and well, this is going to be somehow relevant. Now, this is not only relevant for the cloud, right? So else is also relevant when you compare Java with other technologies like Node and Go, right? So of course, this graph here is not at the scale, but I think we can clearly agree that when you, if you know Node and Go applications, that they are really less memory hungry than Hotspot Java or any other JVM runtime. Of course, I'm not trying to start a debate here on what's best or what is not. And of course, there are reasons why these sort of things happen. But and I'm not gonna go into that because that's like a completely separate discussion. But that's just the fact that we have right now, right? So if you pick Java as your primary runtime, of course, you're gonna require more memory compared to other technologies. And well, here on the Java community, and especially on Quarkus, we want our users and we want developers and the community to be able to compete with other technologies without having to lose anything that Java gives to them, right? Now, on the Quarkus side, the idea is that we were trying to come up with some sort of platform that is able to or can try to compete with things regarding on memory on the CPU as Node and Go. Even if you compare it with traditional native stacks, our idea is that you're able to fit way more Quarkus nodes than you're able to fit as a traditional Java stack. Maybe think about a Wildfly, Jakarta E server, or even a Spring. And I love those technologies; it doesn't really matter. But in here, we're just discussing a little bit of resources. Now, of course, discussing resources that's great, and you might be asking, well, how were you able to accomplish that? And I'll get into that as well. Now we also realize that just coming with the resources argument, it's not completely enough to convince people to move, right? So if you just say, oh, we just use less memory, less CPU, well, for some people might be interesting to change, but maybe for some that's not that interesting. So we also try to offer a couple other things that are more developer oriented, so people can actually see and try to be more productive on a Quarkus platform, right? Now, one of the first benefits, and that's one of the or centric messages that we want to pass, is what we call developer joy, which is we try to come up with the platform which is like zero configuration. It's based on standards, and it is streamlined for most of the code that you're going to write, and then there are like some extension points and flexible for the rest ones. Um, and we support things like hot reloading, right? So, and hot reloading actually works. So you can actually change your code and see the change straight away, just hitting refresh. There is no redeploy involved. There is no restart involved. So it's just like you start Quarkus and then you type your code and you just go as you long, and you see all the changes you're doing on your on your application without any restarts, without any redeploys, which is actually one of the features that our users really enjoy. So all of these is to try to make um, users more productive. Now, of course, the other one that I did mention first, but now looking a little bit more detail, is about all of these memory usages and CPUs. Now, if you compare it with a traditional native stack, we may be thinking about 130 meg. That's some of the measures, right? Um, for Quarkus, we observe things like half the size. And if we compile Quarkus to use growl VM with native mode, you even see a tenth of the size, right? So I'll get into growl VM and native mode deeper into the presentation, so let's not worry about that right now. But at least you know there is that option, and you see that those numbers are quite impressive. Now, if you pick like a more detailed application, and we're calling here like a REST plus CRUD application, so it has like some REST endpoints, an API, database access, right? So you'll see more memory usage on the traditional native stack. So it's not half the size like it was before, but still a considerable amount of less memory. But again, if you look into native mode, you see like a tenth of the size. So that's pretty much linear with our metrics. And again, it's quite impressive to see, in my opinion, this application of 20 meg or almost 30 meg in size for the amount of what you can do, right? you'll observe the same things for the startup times, right? So you'll see sub-millisecond startup times with native mode, and even if you're running Quarkus with JVM normal mode, you see like just a couple of seconds, right? While it's not really unusual to see all traditional Java stacks take 10, 50, 20 seconds to start, right? So it may not seem much, but I mean, for us developers, we are a little bit impatient, right? So everything that slows us down is going to distract us. So if we can go as fast as we can, of course, we're going to choose that route. Now, one other trend that's really popular these days is all the reactive movement, right? And of course, Quarkus is also capable of doing all the reactive stuff, but we do it with a twist in the sense that we try to reuse the exact same APIs that you will use to do imperative or reactive, in the sense that you can even combine both. And if you just want to switch from one to another, you have to just switch a dependency, and that's pretty much it. You don't have to rewrite your application to be fully reactive. You can just pick to use imperative in one situation or reactive in the other. And of course, there are a couple of APIs that might be different, well, because of the nature of reactive. But as you can see, for these couple of examples of these two REST endpoints, they're not really that different. So you still use the same annotations. The response types is different, of course, because that's a reactive endpoint, but it's pretty much the same. And one of the interesting thing is, if you haven't started working with Quarkus, we have like this joke where, well, Quarkus kind of launches maybe like 2-3 years ago, but maybe you have like 7 or 8 years of experience with Quarkus already. And the reason for that is Quarkus is built on top of the most popular and the best frameworks and libraries out there from Java, right? So most likely you're going to recognize some of these logos like Camel, Hibernate, Rest Easy, Vertex, OpenShift, Kubernetes, MicroProfile, Kafka. So all of that comes out of the box in Quarkus. Even for Spring users, we integrate directly with the Spring APIs, and you can use the Spring annotations in Quarkus and build the REST endpoint just like that. Um, Now, to try to, this is really seems too good to be true. Now, I'm gonna go a little bit deep into Quarkus so you can actually understand the architecture, um, and you can actually realize how Quarkus can do all of these for you. Now, probably you already figured out how traditional applications or traditional frameworks start, right? So usually you write your code, and then you have some kind of build tool like Maven or Gradle, and then you build your application. You either output like a WAR file or a fat jar file, doesn't really matter. And from that point forward, that's when a lot of the operations are going to occur. Then you have to deploy it and run it somewhere. It can be like bare metal or cloud. Now, when you run this application, then there are a lot of things that are going to happen, right? So maybe you have to load some configurations files. Then sometimes you have like some class path scanning happening to discover the classes that you wrote with some particular annotations that are going to create like a REST endpoint. And then there is like this meta model build that the application has to start. So if you think, for instance, things like Hibernate, where you have your entity model, right? So Hibernate has to represent that entity model somewhere somehow. So usually that's one example. And then you have thread pools being started. So there are like a bunch of operations that happen when you run the app. Now, on the Quarkus side, we tried to shift this a little bit and try to come up with a way um, to do to build these applications and to reuse some of this logic that happens during runtime, which is when you're starting the application, to actually start only during the build, right? Now, uh, that is going to, of course, give several benefits. But one specific example is, let's just say that you have to read an XML file, then you keep the representation in memory because it is the configuration of your application. Well, that's something that can happen during the build, right? So you build the application with that configuration file, then you can just store the data in that's what we do actually. We store data in a particular format, and then when the application starts, we'll just read the data from there directly, and then we don't have to go and read the XML. A couple of other examples is when you have like all of these libraries like Hibernate or RestEasy or even Spring, all of them are going to do some sort of class path scanning to find whatever they need. And sometimes it's not really uncommon to see like 6, 7, or 8, or even more scans to the class path for libraries to find stuff. Now, another thing that we do is we just unify all of that into a single scan. So there is like a dictionary that we provide, so so libraries can find what they need in a single go. So that also saves a lot of time. Now, what are the benefits that you get from this? So we try to move as much as possible from the runtime to the build phase, right? So not only this is going to save time when you're running the application, when you're starting up the application, but also is going to reduce the number of dependencies that you're going to have on the runtime. So if you pick that example that I gave earlier about reading an XML file, well, if you already read the XML file during the build, then you don't need the XML parsers anymore. You don't need the XML schemas anymore. So you can just throw all of that away. Unless of course you're reading them on runtime, but that's what you're trying to avoid. So by removing those dependencies that you don't need anymore, you're also saving memory. And this is what we do by maximizing all of this dead code elimination. So we see what code's being run, what code it is not. So to remove all of that, and we also do some reflection based code to remove all of the reflection base, or at least try to remove as much as we can. And these optimizations benefit both growl VM and traditional hotspots or the JDK. Now, why is it relevant when we're talking about a cloud infrastructure? Now, if you think, let's just say you're running your application in the cloud and you have to scale to 100 nodes, right? And now you have 100 nodes that take like 10 seconds to start. So all of those numbers are going to add up. And if those 100 nodes take 200 megs as well, in the end, you're going to have like a big chunk of money that you have to pay to your cloud provider. Now, if you're able to run an application that takes less time to start and takes less memory, of course, that's going to be better for your wallet. And maybe the cloud provider is going to be very happy about it, but it is you that has to be happy, right? Now, if you really think about it, this makes perfect sense. It doesn't really make any sense to have 100 nodes when they're starting up. They do the exact same operations, right? It's the same application that's being started. It's the same version of the app. So all the operations are being done are exactly the same. So it's completely wasted time, completely wasted resources to do that in 100 nodes or even more, right? So it doesn't really matter the number of nodes. You only need to have two to make it a waste. So if you try to move, or if you move all of the common things that are required to build time, we're saving a lot of stuff. Um, so yeah, so these are just a couple of examples. So I think so this is the core idea of Quarkus. I think it's really easy to grasp, even though I haven't show how it's actually implemented. And well, I'm not going to show that. Well, it's open source. You can go and check it out how it's done. But I think you're able to understand what the core principle is, and once you understand that, then it's pretty easy um, to also say, okay, now I understand why you're able to save X amount of memory or X amount of CPU or whatever, because this makes perfect sense. And yes, of course, it is not this is not random vaporware that you're just throwing us. This is actually real. So To summarize this a little bit, the idea here, of course, is trying to do the work once and not at each start, right? So we try to move as much as possible during the build. So a lot of the classes that you actually use during the run, they are not needed anymore. So you can just throw them away. So that's less memory. So less time to start, less memory usage, and there's no reflection. There's no dynamic proxying involved. So all you're gonna benefit not only an application that is faster and less memory, but also you're gonna have an application that's gonna be faster as a whole, even during runtime. Now, all of this is provided by Quarkus Extensions. So Quarkus Extensions are actually the magic bit that contains the logic that provides how Quarkus works. And the idea here is that we pick a library, let's just say Hibernate, and we build what we say like a Quarkus Hibernate extension. And then we force, in a way, we force Hibernate to behave how Quarkus expects it to be, right? So there are like a bunch of extensions already out there, so they cover all the popular libraries, and you can even make your own. Now, this is just to tell you that Quarkus is compatible pretty much anything on the JVM, so you can use whatever library that you want. Now, if you want to really benefit what Quarkus gives to you, you have to go for a Quarkus extension. So, for instance, if you use the regular Hibernate dependencies, because it doesn't have all of these that we've done for you, then you're not going to benefit for all the memory improvements and CPU improvements that are out there. So you always have to go for the Quarkus extension to be able to achieve that. Now, maybe you heard other things about Quarkus saying that, well, it's just for small applications or just for Kubernetes or just an heavy compiler. And yes, all of those are true, but I think Quarkus is way, way more than that. Um, so yes, Quarkus is definitely not just an native compiler. Of course, it works great with growl VM, and that's one of the things that I'm gonna talk to you next. It's not only for REST, so you can build it for any kind of applications. You can even be monoliths with it, so it's not only for microservices or serverless. And it's not only another framework, and we're not trying to copy what Spring does. I believe Spring is a great technology. They're great, but Quark is trying to do its own thing. Okay, native image. So I did mention that you could run Quarkus as a native image. So let's see what exactly does that mean, right? So if you heard, maybe you haven't. So there is this really interesting project called growl VM. It's coming from Oracle Labs, so it's already like maybe like 4 or 5 years old, maybe more, maybe 6. I can't remember exactly. And growl VM ships with something really cool. It's called native image, which basically allows you to inspect your application. You actually feed it a jar file or whatever, and then you can actually output a completely binary target from that jar, and you can just run it as you run any binary application, right? So once you have a binary image, you don't run it in Java anymore. So you wrote it with Java, but it doesn't run as a Java application. So instead, you have something called Substrat VM, which is the VM that comes with growl VM as well, which is the one that's built into the image executable for you to be able to run the application. Now, this seems again, this seems too good to be true, but there is like a dark side of this, right? So, and the dark side is, well, it's not Java that you're running, so there are like a bunch of limitations on the growl VM native image mode side. So things like dynamic class loading and or invoke dynamics, security, those are not supported at all, right? And other things that are supported, they have like several limitations. So for instance, reflection. Yes, reflection is supported, but you have to tell exactly what growl VM requires to call your classes or methods by reflection. So you have to say, I want to call this method by reflection. So the growl VM can include it into the binary. If not, then GraalVM doesn't know exactly what's going to be required, and then going to have to include everything, which is not very interesting, right? So when we also started the Quarkus architect, that was also with the growl VM in mind, right? So that was one of the also another reasons why we had to do all this work of moving things from the runtime to the build time to be able to cope with the growl VM limitations, and then you being able to compile your application to native. Now, you also may be wondering, well, yeah, well, you have Quarkus, you can run it on the JVM mode, so you can run it in Java as you run any other application. It behaves exactly the same. You can run it in native mode with GraalVM, so it's going to behave exactly the same. At least that's our guarantee, right? And well, there are multiple use cases where you want to use one or the other. So you may be thinking that you may want to use the GraalVM all the time because, well, it's smaller and use less memory and less CPU. And yes, that's correct. Um, but for instance, the JVM mode is still gonna beat the native image in a lot of other scenarios, right? So if you have requirements that you require high memory density and then you require the best raw performance, right? The JVM is still gonna beat the native mode. But if you have things like serverless, right? If you really need to start like a bunch of nodes really quick to answer like a burst of requests, then the native image is actually good for you. And I mean, when you're running multiple nodes, you can even combine both, and you have like a couple of JVM nodes and a couple of native image modes. It's completely fine. Okay, so I think that pretty much covers a little bit what I wanted to tell you on the theoretical side. So let's try and go and do a couple of demos and show a little bit about Quarkus to you. So let me go and switch here to my IDE. Let's put this a little bit bigger. Oh, are we done with time? Oh, I thought I had like 40 minutes. Uh, it's fine. Okay, apparently we don't have any time for demos. Thank you so much for seeing my presentation. I'm not sure if you have any time for QA. If we do, then I'm happy to answer any questions that you might have.
Yes, Roberto, thank you for your presentation. You have rocked our virtual stage. And yes, we have time for the questions. And now our participants and I want to ask you something. The first question is there a future for monoliths or microservices will shape the agenda? What's your opinion?
Well,
Kind of
I
play.
believe I believe that both are still viable options, right? So microservices, they are not come for cheap, right? So they're not free, right? The uh, if you look into the industry and I'm not sure if all of you are aware, but they were heavily popularized by Netflix, so that's why you see a lot of the Netflix libraries out there that they actually had to build to support them, right? Um, so other things like monitoring, logging, telemetry, right? So because I mean, one thing is you have a monolith where everything is running together, and either it's kind of like a binary, it either runs or not, right? When you see like a bunch of services running around, right, you don't know exactly what's going on, right? So the amount of effort that's required to support a microservice architecture is actually bigger in my opinion, and it's a little bit more complex. And of course, there are all the benefits that you get because then you are able to scale things individually, right? And then you can split the work. Uh, but uh, but
But if
in
we
the end,
talk about Quarkus, do you see Quarkus is good for monoliths as well? Because it's definitely
definitely,
great for microservices.
definitely. I mean, Quarkus, of course, was built with microservices in mind, but I mean, we've seen people building monoliths with Quarkus as well. So all the principles that I mentioned over here, while they'll definitely fit very well with microservices, they are not exclusive to a monolith, right? So you're still going to have all the issues that we had before with like memory usage and CPU usage, right?
Hmm.
So that's also going to be present on the monolith. So you're still going to have the same benefits you'll get on a monolith, where
I see.
you'll
I
get
see. We
on a
have a number
microservice.
of questions, so let's switch to the next. Okay.
Sure.
It's. Thank you for your answer. Vyacheslav asks how to save time on Quarkus native compilation in CI. Do you have some suggestion?
Well, there are some command line arguments that you can use, but I actually wouldn't be too concerned about it, right? So it is a CI. It's something that is like a synchronous, right? That's the idea with the CI. And I mean, there putting more CPUs and memory, of course, also helps. And for instance, if you're using things like GitHub Actions, which have like limited amount of resources, things are going to take a little longer. But I mean, um, the native image build is always going to be slow, and the growl VM team is working to improve that, but it's not going to beat the Java compiler, right? Because those are completely different things. You have to remember that when you're passing in a native executable building, it's kind of like building a C application where everything has to be like analyzed in line, has to be eliminated, right? And when you're building a Java application, as a regular jar file, you just basically it's just like a transpilation from the Java source to bytecode, and then it's actually the JVM that does the bytecode interpretation. So those are completely two different processes, and I mean, there is no really big way to actually match both in the sense that the native compilation is going to take the exact same time as a regular Java compile. That's simply not possible. But there are, if you look into some of the Quarkus guys, you'll find I don't know them by memory, all the command line arguments, but you'll find some things that you can put there to shave some time off.
Hmm. Hmm. Thank you. And there is a question from Valera Dobrodev. Maybe you know about CentOS development plans. It's somehow related to your employment in Red Hat. I'm not sure if you know, but if you have any news,
CentOS development?
yeah,
Yeah, sorry,
CentOS
that's not.
development plans.
Yeah, sorry, I don't think I don't have any word on that.
Okay. Okay, we have also a question about synchronous and asynchronous way to develop something. So
Hmm.
Zen and Igor are asking, what is the best way to do background task for maybe some mobile application, either to do sync or async or some trading or some services. So do you have
I
some
mean
suggestion?
that's always going to depend on the things that you're doing, right? So my usual take on that is you start with synchronous because that's usually easier. Even though the APIs on Quarkus we don't make any distinction and you can use the same exact APIs for both. But I say easier in the sense of debugging, right? Um,
Hmm.
because it's always going to be easier to debug a synchronous application than a synchronous one. And only if you start seeing like things like performance degradation or things that you have like, let's just say you want to build like this huge report that's going to take like a long time to execute, right? Then of course you're not going to make that synchronous to the user. You're going to make that asynchronous, right? So it really depends on the use case. But my general take is start synchronous and only change to synchronous if there's really a strong reason for that.
Thanks, it's clear. Um, Another question is also kind of flame. Spring Boot
Mhm.
versus Quarkus. Why Quarkus and what are the pitfalls?
Well, I mean, we're not trying to compete with Spring. I mean, I've used Spring in the past. It's a great technology, right? And I love the Spring, and of course, I what I believe, and I'm gonna be try to be very diplomatic here, is I think that the community has to gain when you have like multiple choices and when you have uh, multiple things that are trying different things together. In the sense that imagine a world where you only have Spring Boot, right? And we sometimes in at some in some maybe in a few years ago we only had that world. So yes, they made a lot of innovation, but at the same time you didn't have different things to try out. Now, for instance, if you look into Spring, they're also supporting things like building build time compilation and native image mode, right?
Yeah.
And maybe they took that idea from Quarkus. I don't know. I'm just speculating. But what I'm trying to say over here is I think it's better if you have like multiple frameworks where they can try to push each other to have more innovation. They have like a single one where then it doesn't feel there is any competition, and then innovation may fall out a little bit.
Yeah. Yeah. Definitely. Okay. There is three questions from myself.
Sure.
Um, what languages does Quarkus supports beside Java? What dependency injection is used in Quarkus? And how to configure application properties for different tiers like dev, QA, stage, prod?
Okay. So there are three questions over there. Let's see if I got all of them right. So what language we do support? So we support Kotlin, Scala. So any pretty much all any Java any JVM language works. I mean it's Java, right? So it works with Quarkus. Now, for instance, things like Groovy, which rely heavily on things like invoke dynamics, we don't. While you're able to use Groovy with with the JDK and the JVM, but then you're not able to compile Groovy to native. So that's
Mm-hmm.
a limitation on
It's
the
clear.
Groovy side.
Yeah.
The other one for injection, so we
Dependency
use
injection.
CDI. We use CDI. We have our Quarkus has its own CDI implementation. It's called Arc, and well, it works exactly like you could expect a GDI with that inject, and it works like well than what you'll find into Java or Javax or Jakarta now frameworks. And for configuration, so you have application.properties file. That's the main configuration file. Have this notion of profile, right? So you can pass what we call the profile to run your application using quarkus.profile equals something, and
Mm-hmm.
you can say you can run your application in dev mode, in prod, in test. So it's just an arbitrary name. And then if you want to have like different configuration for different profiles, you just name your application properties file as application dash profile name dot properties, and then when you
Mm-hmm.
activate that profile, that file is also loaded, plus the application dot properties file, but one on top of the other.
I
So it's
see.
kind of like a layer. So if you're running
Mm-hmm.
Quarkus in their profile, for instance, then you have application dash dev dot properties being loaded, and then you have application dot properties being loaded after the dev one. So basically, you actually only have to place the configuration that you want to override, and you don't have to duplicate all the configuration. So it's actually works as layers where the the, the layer that builds on top overrides the one on the bottom.
Mm-hmm. I see. Okay, and the last question, it's actually consists of several from Victor.
Sure.
Can you recommend some some materials for studying Quarkus? Also, there is a question about module system in monolith project. I don't know if there is some specific, maybe you can highlight it. And using Guava and updating it to newly versions in Quarkus. What do you think if there is any pitfalls?
Okay, so those three questions again. So the first one, materials for learning Quarkus. So the first one that I suggest is to go to the Quarkus website. So you go quarkus.io. You have several tutorials, several reference guides that try to guide you for several use cases. So saying you how to build a REST point endpoint, how to build a Kafka queue, how to secure your endpoint. So you have all of those examples and tutorials and guidelines. There are also a couple of books. So you can find, I don't remember the name of the book right now. I can try to dig that up, but just try to search Antonio Gonçalves, which is a close friend of mine. He wrote a Quarkus book, so find Antonio Gonçalves Quarkus book and you'll probably find it. So I
Mhm.
can highly recommend that book if you want to give it a try. Um, so you can start for those resources. So sorry, what was the second question? I forgot. Was
Second
about Guava
question
or
was
the model
about
system? Ah,
yeah, module system.
yeah. So Quarkus itself, we don't support Jigsaw or the model system yet, just because we haven't found any use case um right now for it. We haven't seen people asking for it anyway. So that's something that right now we don't support. We have no idea if we're going to support that in the future. But please feel free to come by GitHub. So Quark is an open source project. You can go on GitHub, you can open an issue and say, hey, I think you should support the model system for whatever reason. Here's my use case, and for sure we'll have a look and analyze it. But for now, we haven't found any compelling use case to actually have to implement that.
Okay, and the
The
last question for today. Sorry, we are running out of time. There is still
mhm,
one more question, and
Sure.
it's from Roman Bespalko. Is it possible to use AWS Lambda alias name as profile name for configuration? Currently, it's blocker for him to use Quarkus.
Um, I have no idea. I'll have to check it out. But I think you're asking. I mean, I actually write all the configuration implementations on Quarkus. So if something's missing on the configuration side, feel free to open an issue, and I'll happy to have a look into that.
Excellent.
I haven't looked into the AWS stuff, but if that's a blocker, please come to GitHub, open an issue. You can even mention me directly. My username on GitHub is Rad Cortez, an R, an A, a D, and Cortez, and I'll be happy to look into that.
Great, great. Thank you for all the answers to our questions.
I mean,
It was
it
great
was
presentation.
awesome, the questions. I'm really happy with all the QA that we got. So thank you so much for that as well.
Thank you, Roberto. See you